Storing text in an optimal way is really difficult. But if you have a tree like this, then you will be able to encode a single character in just 2 or 3 bits per character. And today you're going to learn all about how to create a tree like that. It is called a Huffman tree or something. Or is it Hefferman? Yeah, that's probably it. What's up, guys? Welcome to today's show. So we start by counting the individual characters. And then we sort the list in reverse order. And now we pair these up. And we try to make the sum of the frequency as small as possible. So these two become 2, and same here. And these two here becomes 4. And same with those. And this will be on its own for now. Alright, so the last step in this process is to use these pairings and try to make a tree out of it. So we start at the bottom right corner. So we type the Y here and the T, and they together become 2, right? Then we have the I and the R, also 2. Then the U and the A. And the 2 V's. Okay, so these are at the lowest level, all the 2's. On the next level we have the 4's. So we have the E and the P. Okay, I shouldn't have put a circle with them. The 4 should be in the circle, but never mind. And then we have the O and the space. Which is also 4. And we can make additional 4's here. So if we take these 2 at the bottom, they make up 4. So let's put a 4 here on the same level as the other 4's. Like so. And same with these 2. Right, and at the same level we also have the L a little to the side here, which is also 4. So let's continue building this thing. So now we can pair these two 4s here and make an 8. Which will be on the next level. And here we have two 4s, which make up an 8. And this L is 4, but we can't connect that to anything right now. What we can do is on the next level. So this L right here and this will be 8 plus 4. They make 12. And now we only have one possibility, and that's adding this 12 right here with this 8, which makes up 20. And hopefully 20 is the number of characters in this message. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright, that's good. Okay, so this right here is the root of the tree. And on every left side, we're going to put a 0. So from one of these nodes downwards to the left, that's 0. Like so. And then we put a 1 on the other side. So downwards to the right is a 1. And here I forgot a 0. And this is a 1. And we have 1 and 1 and 1. Like so. And this is the Huffman tree. So let's say we want to encode this message right here. So we start with an L. And we start at the root of the tree. That's where we are. And we try to get to this L right here. So first we need to go left through a 0. So we type in a 0. And now we're here. And then we go left with a 0 again. And we end up with this L. So that's the first character. So we go until we hit a character. And then we just continue. So this time we want an O. So we go back to the root of the tree. And where is the O? It's here. So we start by going left with a 0. Then we go right with a 1. And then we go right again and right again. So 2 zeros. And let's do a W as well. It's down here. So we start at the root of the tree. And we make a 0. Go here. And a 1. And a 0. So now we're here. And we go a 0 again. And I forgot to name these right here. But we're here. Let's see. Here is where we are. So now we go 1 to the W. Like so. And now we continue to work through all these characters. And what we'll have is a long series of bits without any separators, and they have different number of bits per character, but we can still always find the right one. Because let's say we want to translate this back to text. Okay, so we start at the root of the tree, and we have a 0, so we go left, a 0 again, we go left, and then we hit the character. So these two are used, and we hit the L. So we type the L, and then we go back to the tree, root of the tree, and we see a 0, and then a 1, and then a 1, and then a 1. And now we're at this O here. And so we'll continue all the way until we have solved this thing. And this is the most efficient algorithm in the world for storing text. It's mathematically impossible to optimize this any further with the bits and pieces that we are using. So I really hope you liked this episode. Please like and subscribe. And thanks for watching. Thanks for today.
Did you learn anything useful today? And do you want to support this channel? Go to drbirch.com/support. You can also click the button Become a Member. Thank you for your support.